Good evening. The Dawn spacecraft is now drawing closer to Ceres, the largest of the minor planets, and is expected to enter orbit around the asteroid on the 6th of March. Here are the latest images of Ceres, taken less than 500 million kilometres away, and the most striking feature is the single bright crater that can be seen as Ceres rotates. The start of 2015 is proving to be exciting. We have a bright comet on view, Lovejoy, which is easily visible during February as it passes between Perseus and Andromeda in the northwestern sky. Binoculars will show it really well. The giant planet Jupiter is in opposition on the 6th of February, and once again we have been seeing some magnificent images of the planet. Take a look at these splendid photos of Jupiter. The first was taken by Trevor Barry on the 5th of January with a 40cm, that's 16-inch Newtonian reflector, showing some nice detail in the cloud bands. The second image, taken on the 30th of December 2014, is by Damien Peach, while this last wide field image was taken on the 4th of January by Tom Pickett, showing the 4 Galilean moons. There are also 2 colliding wind binary stars now on view, Epsilon Auriga and Eta Carina. It is only now that astronomers are beginning to reveal their secrets. I will have more to say about these later in the programme. The glory of the winter sky more than compensates for the relative scarceness of autumn. Orion, the most glorious of all constellations, lies in the south and dominates the scene. Of course, our old friends are still visible: the Plough in the northeast, Vega low in the north, Pegasus dropping to the western horizon, Regulus rising in the east, but all these pale before Orion. The Hunter's pattern cannot be mistaken. Of his individual stars, the almost pure white Rigel is the most brilliant and is practically equal to Capella and Vega, although it is much more remote and therefore much more luminous. By contrast, Betelgeuse is orange and is variable, though always of the first magnitude. The constellation contains the 3 stars of the belt and the misty sword, which contains the Great Nebula. There is a legend associated with Orion. It is said that he boasted no creature on the face of the earth was a match for him. This offended the Olympian gods, who decided to make an example of him. Certainly he could deal with animals, but what about insects? So a scorpion crawled out of the ground, stung Orion in the heel, and killed him. However, the gods could at times be merciful, and it was so on this occasion. Orion was brought back to life and swung up into the sky, where he still shines down in all his glory. It was perhaps fitting that the Scorpion too should be elevated to celestial rank, and this was done. The Scorpion was placed so far from Orion that the two can never meet again. From Britain, Orion and the Scorpion can never be above the horizon at the same time. Orion acts as a splendid guide. In one direction his belt points to Sirius in Canis Major, which scintillates with a lustre far exceeding that of any other star, while in the opposite direction we come to Aldebaran, the eye of Taurus the Bull, which is very similar to Betelgeuse, both in colour and magnitude. Orion's junior dog is marked by the first magnitude Procyon, and not far off are Castor and Pollux, the heavenly twins, who have given their names to the constellation Gemini itself. Here too we have a legend. It is said that the 2 brothers, Pollux was mortal, while Castor was not. When the inevitable happened, and Castor was killed, Pollux was so grief-stricken that the Olympians came to the rescue and placed both youths in the sky. Castor, the fainter of the two, is white, while Pollux is orange-yellow. The rest of Gemini is made up of lines of stars stretching from Castor and Pollux in the general direction of Betelgeuse. Both Eta and Zeta Geminorum are interesting variables, though neither is brilliant. Finally, let us look at Capella in Auriga, which has taken over the zenith position occupied in summer by Vega. It is a glorious yellow star and may be described as a much more luminous version of the Sun, although it differs in being a very close binary. The Capella system consists of a bright binary of giant stars orbiting at some distance from a fainter binary of red dwarfs. There are several nice deep sky objects in view in the winter sky, the most famous being Messier 42, the Great Orion Nebula. The discovery of the nebula is attributed to Nicholas Pierzak in 1610, shortly after the invention of the telescope. Shining at magnitude +4, it is a diffuse emission nebula that contains the distinctive trapezium, a group of 4 embedded stars whose light makes the nebula luminous. It has been a favourite target for astrophotographers in recent weeks, who have taken some really nice images. Another nice deep sky object is IC 434, known as the Horsehead Nebula, also in Orion. The nebula is located just to the south of the star Alnitak, which is the farthest east of Orion's belt and is part of the much larger Orion molecular cloud complex that includes the Flame Nebula. The region was first recorded in 1888 by the Scottish astronomer William Fleming on photographic plates taken at the Harvard College Observatory. The Horsehead Nebula is approximately 1,500 light-years from us. It is one of the most identifiable nebulae because of the shape of its swirling cloud of dark dust and gases, which bears some resemblance to a horse's head when viewed from the Earth. Among the most spectacular objects in the sky are the open or loose clusters, some of which are visible to the naked eye. Some are large and rich, while others are so poorly defined they may not form true clusters. The most famous of these is Messier 45, the Pleiades, located above Aldebaran, the lead orange star in Taurus the Bull. Use the line of the Hunter's Belt as a pointer to the upper right. The Pleiades is a bright cluster of several stars shining at magnitude +1.6, although binoculars will show many more. Many of the stars in the Pleiades have been found to be in rapid rotation, and Pleione itself is one of the most rapidly spinning stars known. While the average rotation period of our Sun is 25 days, Pleione takes 6 hours at a speed of 330 kilometers a second. The star is 3.4 times the mass of our Sun, while the M45 cluster lies at a distance of 444 light-years. The Hyades is a lovely wide open cluster which forms the V-shaped head of Taurus the Bull. All of the main stars are associated with each other, except the bright orange star Aldebaran, which just happens to lie in the same line of sight. The Hyades are 80 light-years further away from us than Aldebaran. While we are in this area of the sky, another nice open cluster is Messier 35 in Gemini, lying above the star Eta Geminorum, also known as T-Jet Prior. Shining at magnitude +5.3, it is on the average of naked eye visibility and covers an area of 30 arc minutes. The cluster lies at a distance of 2,850 light-years and is best seen in binoculars or a low-power eyepiece. Another bright open cluster visible this season is Messier 41 in Canis Major, the Great Dog. This time, using the stars of the Hunter's Belt as a signpost, follow them down the sky to the west and you will easily find the bright star Sirius as it twinkles away. This scintillation is caused by the Earth's atmosphere. High up, the atmosphere is less dense than low down, where you are looking through the full thickness of the atmosphere and including city pollution. From Sirius, move 4 degrees south and half a degree east. The cluster is roughly circular in outline and contains about 50 stars, and there is a distinctly orange-red star in the middle of the field. The stars of the cluster shine at magnitude plus 4.6. Turning our attention to the northern sky, the Plough asterism stands on its handle in the northeast. The two upper stars in the bowl are named Dubai and Merak and are known as the Pointers, since they lead the way to Polaris, the pole star, in the tail of a lesser dog, Ursa Minor. Continue the imaginary line an equal distance and it will take you to the constellation of Cepheus, the King, with a distinctive W-shaped group of 5 stars forming the constellation of Cassiopeia above. The star pattern of Auriga, with its bright star Capella, lies directly overhead during winter evenings. The constellation contains 3 nice open clusters, Messier 36 and M38 inside the main pattern of the constellation, and Messier 37 just outside. It is nice just to sweep the area with binoculars, since there is much to see. There are a small number of deep sky objects of view in the northern sky that make ideal photo opportunities, with several hypergiant stars. Cepheus contains 5 main stars in a pattern resembling a doll's house in the southwestern sky. Midway between the bottom 2 stars can be found Mu Cephei, also known as Herschel's Garnet star. This star may be the largest star visible to the naked eye. It is roughly 3.8 billion kilometers across. If it replaced our Sun, it would extend beyond the orbit of Saturn. The star is approximately 1,000 times larger than our Sun's radius, so you could easily fit 1 billion suns inside its volume. Mu Cephei is a slow, semi-regular variable that is easily visible to the unaided eye when at its maximum brightness of magnitude plus 3.4, but it may be challenging at its minimum of 5.1. The colour of the star is quite magnificent and has been the source of some discussion. It is most often described as deep red or reddish orange in colour. The star is surrounded by a spherical shell of ejected material that extends outwards to an angular distance of 6 arc seconds with an expansion velocity of 10 kilometers a second. This indicates an age of about 2,000 to 3,000 years for the shell. Closer to the star, this material shows a pronounced unevenness which may be shaped as a torus. The star currently loses mass at a rate of around 8 times that of our Sun each year. Just below the star is the splendid nebula IC 1396. The nebula is a concentration of interstellar gas and dust located 2,400 light years away from the Earth. The piece of the nebula that is the dark dense globule IC 1396A is commonly called the Elephant's Trunk Nebula because of its appearance at visible light wavelengths. There is another hypergiant star in Cepheus known as VV Cephei. Shining at magnitude plus 4.9, it lies inside the main pattern of the constellation. VV Cephei is 1,050 times bigger than our Sun, so that it is much larger than Mu Cephei. Messier 81 and 82 in Ursa Major are high up in the sky at the moment and visible in medium-sized telescopes. Join the two bold stars, Gamma, bottom right, and Alpha, top left, and follow an imaginary line to 1.5 times their separation, and you will find them easily. In the field of a low-power eyepiece, Messier 81 is at the top. It is a spiral galaxy, shining at magnitude plus 7.9, while M82 below is known as the Cigar Galaxy and shines at magnitude plus 8.8. Both these galaxies are 8.5 million light years away from us. As seen from latitude minus 35 degrees, Adelaide in Australia, the planet was never visible, and the principal constellations we are used to seeing in the northern hemisphere are upside down in the sky. It is the southern horizon that hosts the south celestial pole, which lies in the constellation of Octans, a group that contains no stars brighter than magnitude plus 3. Therefore, the prominent constellations dominate the northern sky. In the northern hemisphere, the opposite is true. There is a flurry of small constellations with fainter stars in view in the southern hemisphere, depicting creatures reminiscent of a celestial zoo. Although there are fewer bright stars, the diversity and magnificence of the deep sky objects in view make up for this, all nice targets for astrophotographers. The Magellanic Clouds, which are the satellite galaxies of our own Milky Way galaxy, can only be seen from the southern hemisphere. The large cloud lies in the constellation of Dorado and the small cloud in Hydrus, both of which are a wonderful sight in binoculars. During the winter evenings, Sirius, the brightest of the stars, lies overhead in the constellation of Canis Major, alongside Lupus the Wolf, with Auriga and Perseus close to the northern horizon. The bright yellow star Capella in Auriga is actually the lowest star in the sky as seen from Australia, while the distinctive constellations of Orion, Taurus and Gemini are midway up the northern sky. As you turn around and face the southern sky, the constellations of Pictor, Dorado, Horologium, Hydrus and Octans are high and prominently on view. Tucans and Phoenix are high in the southwest, with Antia, Vela and Carina low down. During the winter season, the constellation of Cetus the Whale is setting in the west, while Hydra, the water snake, is rising in the east. Let us now examine two exotic variable stars which are mysterious in their composition. Epsilon Aurigae, visible high in the northern sky, and Eta Carina, which is only visible in the southern hemisphere and is currently on view above the southeastern horizon. Fortunately for us, our Sun is a steady, well-behaved star. It may have periods of unusual activity when its disk is perturbed by spot groups and flares, but at least its output of energy does not alter greatly over the lapse of hundreds of centuries. Other suns are not so quiet. Some of them vary in brightness from day to day, even from hour to hour, either regularly or in an erratic manner. They swell and shrink, and their temperatures change with their fluctuations, so that any planet circling around them will be subject to the most uncomfortable changes of climate. Perhaps the most important of these true short-period variables are the Cepheids, so named because the star Delta Cephei is the best-known member of the class. The periods range from a few days to 6 or 7 weeks. Of much shorter period are the RR Lyra stars, which run through their whole cycle of fluctuations in less than a day. Then there are the long period variables, usually red giants of great size and comparatively low temperature, with periods ranging from 70 days to over 2 years. Irregular variables, as their name suggests, behave in an unpredictable manner. Lastly come the violent explosive temporary stars or novae. The most famous of these was that of 1054, which formed the Crab Nebula. Another type of variable has recently been given the classification of colliding wind binaries, and the two main examples, Epsilon Auriga and Eta Carina, are now on view. Look close to Capella, the bright yellow star that is now overhead, and you will see a triangle made up of three much fainter stars known as the Kids. The stars are lettered Epsilon, Zeta and Eta Auriga. Epsilon Auriga is a colliding wind binary system. About every 27 years, Epsilon Auriga's brightness drops from apparent visual magnitude of plus 2.9 to plus 3.8, and this dimming lasts 640 to 740 days. Epsilon Auriga lies at the astonishing distance of 2,000 light years. The variable star has been studied very closely by astronomers in recent years, and we still don't know a lot about the system. It has long been known to consist of two components which undergo periodic eclipses with an unusual flat bottom dimming every 27 years. The visible component, Epsilon Auriga A, is a semi-regular pulsating giant star. This blue star is around 135 times more massive than our Sun and is 40 to 60,000 times as luminous. If the star were in the position of the Sun, it would envelop Mercury and possibly Venus. The eclipsing component emits a negligible amount of light and is not visible to a naked eye. A heated region has been discovered in the centre of the object. However, astronomer Su-Shu Hang published a paper in 1965 that proposed that the companion is a large cloudy disk seen edge-on from the perspective of the Earth. Robert Wilson, in 1971, proposed that a central opening lay in the cloudy disk, a possible reason for the system's sudden brightening midway through the eclipse. The picture is much clearer today thanks to astronomers based at NASA's Goddard Space Flight Center, and this brings us to Eta Carina, a colliding wind binary system that may be more massive than Epsilon Auriga. Sadly, it is too far south to be seen from Europe. It lies in the constellation of the Keel, which itself is part of the vast constellation which was divided up by order of the International Astronomical Union in 1932 because it was too cumbersome. It was called Argo Navis, the ship Argo commemorating the vessel which took Jason and his companions on their rather unprincipled quest of the Golden Fleece. Argo covered a tremendous area. Its leading star was Canopus, inferior in brightness only to Sirius, and there were also many stars of the second and third magnitudes, plus a rich part of the Milky Way. Finally, it was split up into Carina, the keel, Vela, the sails, and Puppis, the poop. The brightest section is Carina. Canopus, which used to be known as Alpha Argus, has now become Alpha Carina. Here too we have the False Cross, sometimes mistaken for the Southern Cross, which lies partly in Carina and partly in Vela. Not far from it is Eta Carina.
Eta Carina is the most massive star within 10,000 light-years. In the mid-19th century, a tremendous eruption hurled enough gas into space to make at least 10 copies of the Sun, creating an expanding nebula still visible today. New results from NASA satellites, ground-based telescopes, and theoretical models are providing astronomers with an improved understanding of the system. At the nebula's heart lie two giant stars. The smaller of the two is 30 times the mass of the Sun and 1,000,000 times brighter. The primary weighs 90 suns and shines 5 times brighter than its companion. Both stars produce powerful outflows called stellar winds, but the primary's is so dense it prevents astronomers from directly observing the star. The secondary's orbit is among the most eccentric known. Every 5.5 years, when the two stars swing toward closest approach, or periastron, they come about as close to each other as Mars is from the Sun. Eta Carina's most recent periastron occurred in August 2014, and many of NASA's space-based telescopes, as well as ground-based observatories, looked on. Where the stellar winds collide, temperatures reach hundreds of millions of degrees, hot enough to emit X-rays. But the X-ray emission shuts down near periastron when the smaller star is swallowed up by the dense wind of its larger companion. The X-rays gradually recover after periastron, but they do so a bit differently each time, suggesting structural changes in the dueling winds. Recent observations have helped theorists refine computer models of this interaction. Here, darker colors indicate lower gas densities around the stars, while the stars themselves appear as black circles. When the stars are far apart, the winds collide head-on, creating a huge cavity surrounded by 50 million degree gas. But near periastron, the secondary whips around the larger star, carving a tunnel through the primary's dense wind. The secondary star's rapid motion changes the collision zone from head to tail. The smaller star's faster wind flows out along the cavity it created and then crashes into the outward-moving wind of its companion. From our perspective on Earth, the X-rays fade, then recover as the stars move apart. New 3D models of these simulations reveal the formation of finger-like protrusions along the cavity near periastron, features never before identified. Theorists now investigating the phenomenon suggest they may arise from instabilities developing in gas as it flows along the cavity wall. Astronomers also keep an eye on Eta Carina with the Hubble Space Telescope. These images show a structure resembling a crab, formed by gas excited by the secondary star's intense UV light. This light dims near periastron when the secondary passes through the thickest part of the primary's wind. The gas relaxes, settling into a lower energy state. As a result, the crab appears in a different spectral line until the stars move apart and the UV light is restored. Eta Carina is one of the closest and most massive colliding wind binaries, and serves as a natural laboratory for studying these rare and important objects. While its past eruptions remain unexplained, astronomers think they have a handle on its current state, a claim to be tested at the next periastron in February 2020.
Eta Carina has a strange history. It was noted in 1677 by Edmund Halley, who had made a special trip to the island of St. Helena to catalogue the stars which never rise from England. Halley rated Eta as the 4th magnitude, but there seemed to be something exceptional about it. In 1751, the French astronomer Lassell, also in southern latitudes for star cataloguing purposes, ranked it as below magnitude 2. Following another decline, it blazed out in 1837. On the 16th of December of that year, Sir John Herschel was at the Cape of Good Hope, where he had taken a large telescope so as to make the first really detailed and comprehensive survey of the far southern stars. When he looked at Eta Carina, he discovered that it was as bright as Alpha Centauri, so that only Sirius and Canopus was brighter. The next time you look up at Auriga, try to imagine what the star Epsilon would look like if you were a space traveller. And do try to look at Mu Cephei, the most massive star visible to the unaided eye. That is all we have time for this month. Please visit our website, Vimeo, where you can watch all of the past shows of astronomy and space. And if you like this program, please share it with your friends and members of your local astronomical society. Until we come back next month, good evening.